Hello, today we're looking at Module 5, Lesson 11. We're continuing to learn more about equivalent fractions. We've already been using tape diagrams and an area model to show equivalent fractions, and we've used multiplication and division. Today we're also going to look at number lines to show equivalent fractions. We're going to start with the number 1/3, and we're going to show several different ways to find an equivalent fraction for this. We're going to start with one that we know. So let's start with this tape diagram. To show 1/3, we're going to split this up, and this tape diagram represents one whole. So we're going to split it up into 3 equal pieces to show 1/3. Now, each piece, if we split it up equally, we're basically decomposing it into smaller units. And as long as we keep them the same size, we can still show an equivalent fraction. Let me go ahead and highlight this 1/3 so that we can see it. So here's our 1/3. And if I go in and split up each third into 4 equal pieces, we've now created an equivalent but smaller fraction. And this isn't anything new. We've been doing this for a few days now. How many pieces are shaded in now, and how many pieces does it take to make a whole? Our numerator is going to be 4 because there's 1, 2, 3, 4 pieces shaded in. And our denominator represents how many it takes to make one whole. So we're at 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces to make a whole. So we can see that 1/3 is the same as 4/12. All I did was break apart my thirds into smaller pieces. We can do the same thing on a number line. Now I'm going to transfer these lines over from the tape diagram onto the number line. This represents 0 because we're starting with no pieces. And over here, this is one whole, or 12/12 in this case. So I'm going to go ahead and split this up into my thirds, and then each third I split in half, and then each of those I'm going to split in half. And I end up with my 12ths. Let's just double check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I have a number line that's showing 12ths, and we want to show equivalence. In this case, we're looking at this number right here, 4/12. And we want to show that it's equivalent to 1/3. Well, if we take this same number line and we mark off where the thirds are, we would mark right here. I'm going to make it a little bit taller. And we would mark off again right here. And these lines actually match up with those original lines that we used on our tape diagram to show 1/3. So this spot on the number line is also 1/3. This one's 2/3. And 1, 2, 3, 4, 5, 6, 7, 8 twelfths. And what we're saying here is that these are equivalent because this shows 1/3, but it's also showing 4/12. If we look at these pieces, it takes 4/12 to make 1/3. And let's write these out as a multiplication problem and as a division problem. So with our tape diagram, we started with 1/3, and we said that if we split up each piece 4 times, the shaded ones and the whole, remember what we do to the top, we do to the bottom. That'll give us 4/12. Now with our number line, we started with 4/12, but what we said was, if I take my 4/12 and I group them into groups of 4, so here I have 4, here I have 4, here I have 4, then what I'm going to end up with is 1/3. So now we have equivalent fractions with a tape diagram, a number line, multiplication, and division. The thing that I like about the number line is that you can have multiple fractions landing on the same spot. And since that spot is the same distance between 0 and 1, it's showing that they are, in fact, the same amount.